Right. So lifetimes, right? So firstly, I think what you need to know is, if you don't already, um, is that the main thing about lifetimes, there are two things you need to keep in mind. One is that it's not the lifetimes is just an implication of the strict ownership model in Rust, right? So um, everything you see, all the resources you have in Rust, they have a lifetime associated with them. Um, oh, the font size is small. No worries, I can increase it always. Wait a second, that's too big maybe. Is it good now? Or is it still small? Okay, I'll assume it's big enough for now, but I can increase this later again. Yeah, so everything is. This codec seems to hit. Hey Alberto! Little small here. Okay, let me increase it. But then I'll resize the window so I can see the chat. Oh, and by the way, there's I think a bit of delay in the chat. Is it good enough now? The text size? Good. Wow. Well, I think I'll try next time keep it white background, but it's too much for now. Yeah. Okay. So yeah, where was I? Can I continue? Okay. So ownership, right? So everything has ownership. So every resource has only one user, and that's where the lifetimes concept come into play, right? So for example, right here, I created, by the way, this just now before many of you joined. It's with Cargo New, I created something, and it just, this is the default what you get with Cargo New package. So this string itself, like it's a string and it's a resource, so it has a lifetime associated with it, but it's a string literal. So we will talk about the static lifetime, special lifetime, which is static, that is associated with it. But let's start small, right? First, let's talk about, like, let's say we don't need lifetimes at first, and a lot of times you actually don't. This is true, but what I keep telling everyone is that don't believe that you don't need to know or understand lifetimes. You do if you code in Rust for a while. Maybe you can avoid it in the beginning, which is fine, but later you will need to understand it. So that's why I wanted to have this session. Let's say struct alpha, whatever. Sorry, I'm used to C still, so I first write the type before I write the name. It's a that's not a good name. Let's make it a bit more meaningful. Let's say age. Well, U8 is more than enough for person's age, I would guess. But if not, U16, whatever, it doesn't matter. So this is like a struct, right? And if you create this struct, it's all good. I have the Rust analyzer enabled in here, so if there was a problem, it will tell me, hopefully. And you can just, create that p is equal to person age. Let's say it's an old fart like me, so 39. Yeah. Hello. I'm not putting name yet for a reason. 1 second. And p.age, right? And we can then just powder on it. hello person of second hand. So there was no lifetime problem you saw. And but like it's a basic type, right? So it doesn't matter. It gets copied, it gets moved. It doesn't matter. Also, it's like this can be completely on the stack. It doesn't need to be allocated dynamically because we know the size of the struct because we know the size of every field. But let's make it something that is dynamically sized. Let's say we also want, let's say, name, and that's string. So we choose a type that is owned, which means that it doesn't have any references. We will talk about reference later. And of course there's a problem, we didn't specify the name, so age name equal to Nishan, and then of course it doesn't accept it because it's not a own string type. I was passing the string literal, which is not the same as string, and there we have it. RAM, same thing again. It's all fine. So again, lifetime didn't come into play because we used owned type. And one thing to talk about is when we talk about lifetime is, as I said, everything is lifetime, and the lifetime is associated with something called scopes. So each of these curly brackets, like between these, when you have some variable, you have one owner for that, for each resource that you have in there, and you have the lifetime that every resource that you create within this one scope, the lifetime is associated with that scope that you define with these curly braces. So it doesn't have to be just also only a function. It could be, let's say, this. The valid Rust code, and then now you have defined a new scope, and this lifetime exists within this scope but not outside. If I create, for example, that a is equal to 40, 85, whatever, doesn't matter. So the scope of this a is throughout the smallest brackets it's within, and that's the scope, and that's also the lifetime of it. So the lifetime of the A is throughout this scope. Anyway, let's undo this damage. So so far we have this, and another thing, like when you start and you haven't dealt with lifetime and you want to avoid it or whatever. And a lot of things, even when you know lifetimes, you still don't want to involve them. So one of the ways of a trick that I learned recently is that you don't need to clone everything. You can avoid cloning by using something called RC. RC. It's a reference. It creates reference counting around a resource. So when you clone an RC, the inner resource doesn't get cloned, but instead you increase the reference counting. Only the outer RC struct, which is just a struct, and it's like consumes, like for example on 64-bit computer, just one register. So it's as good as a pointer itself. So it's like a smart pointer, as you would call it in C++. And then what you can do is you put all your actual data in a different struct. Let's have it anonymous. So RC on that's it, and then sorry, person. We need to give a different name, of course. Person inner, and of course this won't work with our usage because we don't. It's a different struct now. But if you use something like this, you can expose the outer one in your public API, outer struct, and the inner struct is just an internal detail which is in an RC, and all your data is it doesn't need to be cloned. You can clone that struct as many times as you want, and the inner data doesn't get cloned. So that's already an efficient way of doing it. The lifetime doesn't usually come into play when you deal with something temporary, and you want, let's say, let's remove this, and let's start involving lifetimes, for which we are all here. So firstly, let's say implement person. Wait, let me look at the chat. Someone's saying something. Seems like 10 rupees too much for my connection. Oh no. Maybe I should have chosen 30 frames per second. So yeah, are you guys following so far, or am I going too fast or too slow, or? You can type in the chat. I'll keep talking while you write the message. So yeah, let's say you have fn and self. Sorry, need to give it a name. Let's say name, right? And then str. That's the unowned version of string. And then you say self dot name, but you have to dereference it because it's a own type. Hello. Right. So it says unused, but that's okay. But we can use it here, for example. But as you saw, like we used references here, but it's not a problem. We didn't have to specify lifetimes, and the reason is that Rust does. There's a lifetime elision, it's called. So it does allow you to, in certain cases, not have to specify lifetimes. Oh, and another important point about lifetimes is that when you have to specify lifetimes, you're not specifying lifetimes. You're not creating lifetimes. Lifetimes is always there. You're specifying them. You're specifying their relationships, and you're specifying which reference is which lifetime. And then you can specify relationships between them. That we will look into later, specifying relationships. So yeah, there's lifetime is always there, especially when it's a reference. So in here, the lifetime is there, but you just can skip it, specifying it, because it's a simple case. What else could it be? Like if you how do I make it a problem? Right. Let name name equal to hello. Right. Use this name. It says it doesn't need to be mutable, but it's okay. We will get warnings, but it's fine. Hello. Well, that's not a good name. Let's say Alberto. Anyway, and now if we try something like, well, how do we do that? Yeah, okay. So we're giving P a different lifetime than the main, a different scope, and therefore a different lifetime. And now if we say name equal to p.name, that won't work, right? Let's see what not found in the scope. It's a different problem. There we go. Now we get to the real one. So you see, borrowed value does not live long enough. right? Um, and why? What's the reason? The reason is that when we get the reference, the inner reference of something that this struct has, that reference is tied to the struct itself, because we are getting a reference to something that belongs to the struct. Like as I said before, it's strict ownership model. So the name string here is owned by the struct. So when you called this function on it, you got a reference, and then when this scope ended, this whole this p that you created, is gone. It doesn't live anymore. So when you later use it, you can't use it because the owner is gone. So that's the problem here. But the thing is, like, this is an ownership problem. This is not a lifetime problem. So even if you specify a lifetime yourself, there's no way around it, because if something is gone, it's gone. By specifying lifetime, you don't extend the lifetime. You can't do that. All you can do is make sure that Rust knows what the lifetime is. So in a way, this was not the best example. So, but let's say we want something temporary, right? So you never need person more permanently. You always need it temporarily, in a way. So instead of using an own type, we say we want to keep a reference here, just like that. Let's say this. And now we will have a problem. This we can do, because we didn't specify a lifetime for it. And in this case, Rust cannot automatically detect what would be the best lifetime. So you specify a lifetime, let's say S, or N for the name. You can, by the way, like usually people use one letter lifetime specifiers, but you can use like multiple. I just saw the number of people dropped. They're gone. No, but I don't know why it says 2 users. Everyone is here still. Okay. Anyway, so you can say name here even, and then name there. So, and a lot of times, like, it actually makes sense to give it like meaningful names, and then it's much easier to read a code with lifetimes associated. Like, for example, if you use Serde, in Serde the lifetimes for the deserialize, you will see that it's DE, like tilde DE, and that makes it so much easier to follow, like, okay, what lifetime you're talking about. So yeah, let's say name, and then it's super obvious what it's for. And now, since we specified that, we have to specify a lifetime here too. Right, and instead of this, what we are doing is, I don't need to be mutable. What we can do is name equal to Zishan is gone. Actually, we don't need to specify this because it Rust, the newest, well, not the newest, but for many months now, you can specify, or maybe a year. If the field name is the same as the variable name, you can just use one name, and that's it. All right, there are warnings, but let's see what the warnings are. So yeah, it compiles, but the reason is that the name, that's like, it will be around while P is around, so that you have specified that this string that is assigned to the name in the person, it will be around as long as the person is. So that's what is implied here. and it's true in here because the scope, it's the same scope. So the name will be around as long as the person is around. How do we make it not be around? By the way, if you ever have any suggestion to the questions that I myself have, please do say it. You can help out if you want. So we want the name not to be around while the person is still around. Right. Let's do it this way. And then do this. Actually, we can just directly do this. Well, let's not do that. And it can be like a string, you know. Oh man. And then p dot name equal to name, right? And then we have p. Well, this will already be a problem because even if we don't use it here, it will be a problem here. Mismatch. That should fix that problem. Let's see that. Man, sometimes Rust is annoying. See, now we have that problem. Live does not live long enough, borrowed value does not live long enough. So we are assigning it something that doesn't live as long as p, and that's not possible because it has to be the same lifetimes. Right. So yeah, that just demonstrates like you can't have pass a reference that doesn't live long enough to the person struct, because the struct is living longer than the variable that you're assigning it or the reference that you're assigning it. And you can right, let's create a constructor for it, right? fn new, let's say call new, and each again name and tr self, and then same as here. Let's use self age and in here we have to specify lifetimes. I mean, how else would it know like how long does this this reference lives? So the simplest way is like always to just use the same lifetime, but that can sometimes get you in trouble. Because if you have multiple references, for example, and you give them the same lifetime, then Rust will expect every reference you pass to that specific structure, which is assuming the same lifetime or the function. It expects it to all have the same lifetime, which may or may not be true. Okay, let's have an example of that after this. So let's say and name the same lifetime that we have already declared. We give it and see. That should work, and it does work. Let's not do this. Let's keep it in the same scope, and then it should be fine. With a lot of warnings, but that's okay. Never used. It's okay. Let's use it. Not much difference anyway. Just that we don't need to specify the names. Sorry, I'm still on Vala in that respect. Yeah, like it compiles with some warnings. So that's good because you told it the lifetime, right? Let's say we had more references here. Let's say some identifier, right? Identity card number, whatever. ID number. ID. Oh, let's call it that. And let's give it the same str, same lifetime, right? Now, well, we need another one of these. Now we need to give it some ID. Let's say that's part of my ID number from Finland, so let's just give it that. Yeah, it's fine. Like you give it the same lifetime, but in this case it doesn't matter because the lifetime you're using is static anyway. And when you specify static lifetime, and you can also say like this, for example, like you can say static, right? And if you do that, actually you don't need to declare it because this is Rust has specified this already. So if you do this, I don't think you need to specify it up there. Of course the lower code doesn't work, but the upper works. And what this means is that this the static usually means that it is valid till the entire lifespan of the program, but in this specific case for lifetimes, it actually more when you use it as a specifier, it means more like it outlives all the other lifetimes. So it's never a problem if you use static. So the only references you can use here are the ones that will live at least as long as the person, right? And yeah, so then it's usually not a problem if you can use static, but typically it's not a good idea. Like you can't guarantee static, so you have to provide custom lifetimes, so that Rust compiler can tell which variables live long enough, which don't, and stuff. And that's why it wants you to always do that. Some example of that, right? Let's see. This one. This works. Okay, good. Now let's say let ID is equal to string blah, doesn't matter, and then we assign p dot id equal to and id. Is that a good test? I want to try to test how if you give it the same lifetime to different references, how can I break it? Any ideas? like when would it be a problem if you have the same lifetime specifier for both, but so one of them don't live long enough, but the other lives long enough. Anyway, if you don't have ideas, I don't have either. But just trust me when I say this, that you generally, for different lifetimes, you want different different references, different lifetimes, and within the struct, you don't need to do that. Like that's fine. But when it comes to passing to functions, that's where it comes in handy, and that's where the relationship between lifetime specifiers come into play. So let's say you have two references, lifetimes, and then you have I. Then you say and I, right? And now you will have a problem because Rust doesn't know if the custom lifetimes you specified here, outlive this lifetime or not. What is the relationship between those lifetimes? And so that's why there's an error. Let's see the actual error in full. You can see it here. Lifetime of reference outlived lifetime of borrowed content, which it could happen. You can give it a reference that doesn't live long enough as the inner lifetimes here, the ones you specified for the fields. So how do we handle that? Actually, let's make it not name so that it's more clear. So let's call it lifetime of person. So let's just call it P to make things easier, because now we have multiple lifetimes. There we go. So how do we specify relationships? By using this operator. Let's make it more clear by writing separately. Usually you write it like this, but let's do it this way. It's easier to read. And now it works. And why does it work? Why is Rust now happier about it? Because what you say with the colon, and a very easy trick to remember what this colon means in lifetime specifiers. For me, it helped a lot, and now I read them very easily. Like previously, I was reading it and I was like, "What does it mean? Like, what's happening?" And when I use this trick to think of the colon as greater than sign, it all clicked in place, and now it's so much easier for me to read a lifetime specifying. Like even there are multiple when there was multiple lifetimes specified, at least more than 3, my mind would just blow up. So I just couldn't follow. But with this trick, I can follow because I read the colon as a greater than sign, and what that means is that the n lifetime outlives the P lifetime. You're telling Rust that the lifetime that you're assigning, that you're specifying for name variable here, outlives the lifetime of P, which is the lifetime you are using for name, for example, and also for ID in the struct. So that means it will never be given a reference that doesn't live at least as long as the struct itself, and then it's of course fine. Yeah, don't actually use greater than sign because that's not the syntax. I wish it was actually, because that would make more sense and it would be so much easier to follow. So yeah, that's how you specify relationships between lifetimes, and then Rust can tell. And then if you misuse it, it will give you errors, like it did in here, for example. So in here, I think this is fine because we don't use P after this scope. But if we did, then it will of course give us an error that we are assigning it ID which doesn't live long enough. So yeah, that's a valid error. And so how do you get out of this error? The way to do it is that do not use data types. I forgot the word. Any data type, enum or struct mostly, that uses lifetimes in non-temporary. Like if you need to keep something around, just don't use anything like that, because then you're just calling for trouble, right? Use own data. For example, in this case, I would just use string string, but if you need to, if it's a data that needs to be cloned a lot, or at least enough, so that performance could become a problem, and you want to avoid allocations in general, just use the RC trick that I showed you earlier. Yeah, just do that, and then cloning is a cheap operation. And actually, we did that recently in ZBus. If you are on this stream and you don't know what ZBus is, it's an awesome DBus crate that you can use, and I'm the co-author of that. So we had a problem that we had a struct for the connection. So the connection to the bus is represented, or to the peer on in there is represented with a connection. But we had a lifetime on it because we had some unknown data there. For example, let's say unique ID or unique name, I think it's called, and that was NC str. It was using that, and yeah, it became a bit of a problem. So what we did was we turned it into the RC type, and sorry, actually I'm misremembering. So the connection itself was fine. It was using one type, but there was another type that was keeping connection in it. I think it was proxy and object server. I think object server, and it needed to, of course, need a connection around. How else would it talk to DBus without knowing? And it was like this, because you could have multiple object server, and especially in case of proxies, you could have like thousands of proxies easily in one program. So it was initially like this, and of course then it needed a lifetime. Right. Sorry. And that was a problem because how would you keep it around? Like, it's if you have unowned data, you just can't keep it around. Like how? You need someone to keep ownership. The ownership needs to belong to someone. And when you are using a reference, you are not the owner. You are a borrower. So yeah, someone needs to keep it around. So where would you keep it? So it didn't make it easy to use it. So that's why owned data types are much easier if it is something that needs to be kept around. So in this case, what we did was we made it own type. Well, we still kept the lifetime, but the lifetime is more or less now static because we need to keep the lifetime around for backward compatibility, like API breakage. Otherwise, API breaks, and we don't want that. But in essence, it's using the. So what we did was we made connection into something that's very easy to clone. So we called it connection inner, and we did this. Yeah. So this went there, and then what we did was just let this RC connection inner. It's fine. Right. Sorry. Yeah. And then if we use like connection, we use a cow. It's a very let's talk about it in a second. I'll put a and talk about cow later. But anyway, let's say we did this and we broke the API. So now we had connection, and it's not a problem, because if you create multiple object servers, for example, or let's say proxies, which is a lot more realistic. You don't want a lot of object servers actually, but you would need thousands of proxies in some cases. So yeah, and you want connection in it, not a problem, because cloning connection is super cheap now. It's just as expensive as incrementing and decrementing a variable, and it's not even needed to be thread safe because it's RC, not ARC. So it's all good. So you can use those tricks in that. And another thing to keep in mind, if you want to be able to use both owned and unowned tabs, is to use cow. Let's say, for example, here, what you can do is you can have a lifetime, but it's not a problem because let's say yes, because the cow is copy on write, but it can keep both owned and unowned values, as long as the data types, underlying data type you're using has a way to move from unowned to owned. So when you're not cloning it, it's fine. You can keep it unowned data, but as soon as you clone, it can be the inner type can be cloned at that time, right? So you specify lifetime, I think, and how do you? I forgot. I always forget the syntax for it. What is the std colon borrow? I think cow. Wow, I remember. And then you can keep a string that is both unowned and owned. Yeah. Well, then we need lifetime here as well, and there too. But it's in case that when you put a borrow owned value in it, like a string, like with a capital S, then it's okay. Let's remove all this business. That was I was just telling you a ZBus example, like an actual practical example, just to show you. Right, and all of it, and then yeah, you can create the person name, and then you can say cow from. You can provide constructors that where you don't need to say cow from. For example, you can say, let's say fn person implement. Yes, I make a lot of typos, especially when I'm a bit nervous and a lot of people are watching. Fn. What are they doing? Yeah, constructor. Name column. Okay, that's a new str, right? And then and str. Let's say p, right? And then self. And then you can say this actually can have two constructors, one str, one string, and this one would be like just like this. Call from name, right? And this goes away, and this one takes a string, and then same as here, same as there. Right? So you can say both of these, name, person, column new str, and there you can see this. It's not a problem because the lifetime here is static. For string literals it's static, so it outlives all other lifetimes, so you don't need to, it's not a problem. Yeah, so new string from, or you can just make say toString. So both are fine. So as I said, like with cow, you can use both unowned and owned, and when you clone it, it will automatically clone as needed or make it owned. But the value needs to implement a trait called toOwned, which turns an unowned to an owned value. So yeah, that's all you need to do. So you can use string here. You can also do the same for slices. For example, if you have byte slice for anything or any other kind of slice, you can use that, and then it will, like, the own version is called a vec, so it will automatically be turned into a vec if you clone it or copy it or whatever. So yeah, cow is a really, really useful a data type from standard library to use, and you can avoid allocation if needed from there. Using that, I mean, you have both the advantages of unowned and owned. The advantage is that if someone wants to create this struct of yours and they don't want to allocate a new string, they can use your struct without allocating or copying any strings. And if they want to keep a owned value and they want to allocate and stuff, they can do that as well. So it's super awesome in that respect. So I talked about lifetimes, I talked about owned and unowned types. I also showed some tricks like how and using RC inside your struct to avoid having to deal with temporary values. And I also told you about the relationship between lifetimes, and a trick to remember how the relationships work between different lifetimes. Is there anything you want me to talk about here, or try to give you an example of? Or if I didn't explain something well, please let me know. I want to explain it well, and because if I know something, it's like in the back of my mind, right? I take it for granted, some of the things, after knowing them. So I would need someone who doesn't know it yet to tell me what's unclear. Yeah. So please tell on the chat if you have any suggestion of what you want me to talk about. I'm waiting. Still waiting. Waiting. Yeah, it takes time to type anyway. I really wish they in this one they had a way to enable voice chat from the viewers. Um, like at least if I want to give someone voice, it should be possible, right? Like so that they don't have to. Is there a way? No, I don't think so. Whisper. No, I don't want to block anyone. Right, if you don't have any question or if everything was clear, could you just please type it very shortly so that I know? And I'll think about it too for a minute. And then if none of us can think of anything, I'll turn off the stream then. And everything is. No problem. There's background noise? I don't hear anything. Oh, from outside. Yeah, there's a kindergarten downstairs. So, yeah, the reason I didn't use headset, I actually almost always use headset for meetings. And the main reason is in there is the echo. But in this case, there was no echo, so I didn't bother. But I didn't think about the noise from outside. Or maybe I should close the window. But yeah, I also like the headset on Linux. I don't know. I'm always expecting it to break, although it works. But I'm using the laptop's mic. Yeah. But I hope that you could still hear me even with a bit of noise. Oh, the buzz! I know what the buzz is. It's the laptop spinning the CPU fan, the heatsink fan. Okay. Sorry. Yeah. If I had thought of that, I would have used a headset. Even though I fear that it might break on Linux. Fan gain. No, I'm not looking for fans actually. I just want to give some, if I learn something, I want to give it to others too. And yeah, but yeah, I want people to be Rust fans. So yeah, in that regard, it should be helpful as well. Yeah. Okay. Good to know. Next time I'll do that. Yeah, cheeky. Right. Yeah. Also, if you have a suggestion about, it's so funny. I was about to say that if you have suggestion about more sessions, it would be good, and especially if you want some session about Zebus, I can do that. Oh, example of how to interact with RC? Sure, I can do that right now. It's well within the scope because I talked about RC. Right. No worries. Lifetime. Oh, RC. Sorry. So yeah, let's do that trick thing that I was talking about. So instead of call, we use RC string instead. Well, actually, yeah. Well, you can have recursive RC, that's not a problem, but I do not do that. Sorry. So lifetimes go away. We could have that, or let's just say string. Excuse me. And then person can have person inner, but it has to be in RC. So you say RC colon new, and just put the thing that you want in it, and then it's inside an RC. 1 second. Okay, because I need to use it like this, like, what do you call this kind of struct? It's not a fieldless struct. This, I forgot the name for that. Oh yeah, we don't need this anymore. Name, actually, it can be this. Right. No worries, Markdown. Yeah. Then new. Click on new, right? And then the thing is, you can't access name like that, right? So what you can do, like you access that 0 dot right. So yeah, it's like RC. Just there's a trait in Rust called deref, which means that you can dereference any type to the target type. Like you define it, like I want, for example, string type has implement deref for string, and then there's a type target equal to and str. So you can deref then a value which you can. The reason is that there's a deref implementation for it, that you can dereference a string as a str. So when you have a string and str, you can just do this like that. S is equal to string whatever, and then you can do and s and use it as a and str, because there is a deref implementation for it. So similarly, there is a deref implementation, a generic dereference implementation for RC. So you can use RC as the inner type that is in it. And the cool thing is that the dereference is implied when you use dot. There's a few operators when you use them, the dereference can be implied implicitly. And another one is this one. When you do this is another way to invoke a deref. So yeah, the Rust will deref for you as many times as needed, recursively, until you get to the target type, and then you can use it as that. So using RC is just like using the inner type within the RC. You don't need anything extra. Lechek. Are you the Lechek that I know? From real life, I mean. The one who flew with me in plane. Anyway. So yeah, that's how you use RC, just like a normal thing. You don't need to do something special. But RC, like for mutable type, you don't use RC because the RC is not mutable. So when you deref it to an inner type, you're getting an immutable deref. So if you want mutability with RC, you need to use other data types like mutex, or for single-threaded use case, you use something called not mutex, cell and ref cell. ref cell. They're very closely related, and I keep forgetting which one is for which. So, but you can always read the standard library reference docs to know which one to use for your use case. But yeah, ideally, it's ref cell is mainly meant for references, and cell is meant for non-references, own types. But also there's mutex. But mutex is more like for multiple threads, which you use with something called arc, which is the same as RC, but it's atomic, so you can use it with threads. RC you can't use with threads. Only arc you can use with threads because it's atomic. Anyway, so that's how you use it. That was a very quick introduction, but I have a talk which you can watch, Rust Memory Management, where I talk more about different types of data types that you can use, like RC and ARC and stuff, that you can watch on YouTube. And there's actually I wrote a blog post too.